Okay, it looks like everything's working now. Okay, so let's go ahead and start with the warm up. I'll go ahead and explain that real fast. I just have to. Okay, I think we're working now. Okay. Okay, so let me wait for my Promethean to pop up real fast. Okay, all right. So for this problem, it's a steel ball that's dropped from a height, and then it shows you that at the top that it has all potential energy, right? And that the kinetic energy is 0. And then as it falls, that potential energy turns into kinetic energy. And at height equals 0 at the very bottom, right as it hits the ground, its potential is 0 because it has no more height, and its kinetic is 600. So based on that knowledge, you know that the total energy of the system is 600. And so you also know that in a perfectly closed system, that the mechanical energy, which is the sum of PE and KE, that's PE plus KE, you know that the mechanical energy is going to be the same number the entire time. So that anywhere on that path, PE plus KE is going to equal 600. And you know that the higher it is, like next to this one, right? It's losing PE, but it's still going to have more PE than KE, right? And maybe it lost just a little bit. Maybe it lost just 100 joules of PE right here. But and then since PE lost 100 joules, then KE would have that 100 joules. And then, so on and so forth. A little bit further, PE would lose a little bit more. And then maybe at 45 meters, which is half of 90, that their energy would be halved, because if you half the height, then that halves the energy. So maybe halfway mark, PE would be 300. And so you know that KE would also be 300, because remember, it has to equal out to 600 because that's the mechanical energy of this system. So the question is, what's the PE and KE at 36 meters? And so while it might look like you would need to calculate something, you don't, because you can just reason with that information. You know that this is more than halfway down, so he more than likely has more KE than PE, and that it also has to equal out to 600 when you add them. Okay, that makes sense too, because this first one right here, 360 plus 360, that's 720, so that's not going to work. 240 and 240, that's 480, and that's below 600, so you know that's not going to work because that's not conserved. But these last two both equal out to 600, but remember, it's closer to the ground, which means there's more KE than PE. So this would be your most logical answer. The PE potential energy is 240 and the kinetic energy is 360. Okay, so this is the warm-ups. The last few warm-ups that I've done are questions, actually the direct questions that I've taken from old tests. Usually I try to change them a little bit, but I didn't. So the warm-ups are always good, and especially the exit tickets too. I do just kind of grab my questions from old tests. Okay, so the assignment that I have in the folder for you today is the second relative assessment. And so this lab is going to be in the same category as the egg drop project. So it's good because now your grade isn't so dependent on the egg drop project, but still a lot, right? Because right now the egg drop project is 30 points of your grade, of like your report card grade. And when I add this grade in, this lab, then it becomes only 15 points of your report card grade because this one's going to be the other 15 points. And so what's also nice is the teacher who created this put in a rubric so that you know exactly where the points are coming from. I think that helps y'all kind of see what you need to do and where points are going to be taken from. So you can kind of look at this to double check your lab to make sure that it's perfect when you turn it in. But let's go over it. So you will conduct an experiment to investigate energy conservation and energy transformations. So click here to open the lab instructions. So this right here is the lab instructions that you need to follow through to do your lab. So the first part is when you're actually collecting the data. So you will need like a bouncy ball, or like a tennis ball, or like a racket ball, or anything that bounces. You could probably use a basketball. Soccer ball might be a little bit harder to do. Are they pretty bouncy? Okay, well then make a soccer ball. If a basketball works, then probably a soccer ball. But you could probably just raid if you have a sibling, their toys to see if they have just like, you know, those little cheap bouncy balls like this. And the other thing that you can use is, have y'all seen these before, this little popper? If you have these at your house, you can also use this for the assignment. And so then you need a ruler, a meter stick, or a tape measure. So a lot of people in their garages have one of these. You can decide what you're going to measure in. So if you feel more comfortable with inches, that's fine with me. Or a measuring tape, like if you have someone in your house that sews or has a sewing kit, those very frequently have those, like, you know, those, they're like not string, but they're like, they, you know, they measure like your waist or something like that. That works, or a ruler, anything like that. And then you're going to record your data in this Google Sheet that's right here. So I'm going to make a quick copy of this because whenever I type in this master copy, it types in everybody's. And then I'm going to pull this out. Okay, so basically, in an ideal world, if you drop a ball, if there was no friction at all, and you dropped a bouncy ball, and then allowed it to bounce back up, it would bounce back up or rebound to the exact same height, like this. Let me show you. Like this. So you would drop it. Right? And then the PE here would turn into KE here. And then it would have enough inertia to bounce back up and make it to the same height, where the KE would turn back into PE. And then it would do that forever and ever because it's perfect physics world. But we know that doesn't happen. So in real life, right? So when it falls back down and then comes back up, it only reaches like a certain height because energy is lost, basically. So energy leaves the ball because of real life friction or whatever. And then if you do it again, it'll go even lower and lower until all the energy is lost. And so what we're looking at is how different surfaces affect that rebound height of a bouncing ball. Quick question: if my ball falls to earth, take the first one right here. When it falls down, is work being done on the ball? Okay. what's the force that's causing the ball to fall down? Gravity. And it's being displaced in the direction that that force is pulling in. So, and that's what work is, remember? Work applies a force that moves an object a distance in that same direction. And so whenever the ball falls, gravity does work on the ball, applies a force that causes it to move down. Work also transfers energy. So work, or the gravity, while it has potential energy, gravity does the work on it and transfers that energy into kinetic. Okay. And so also, you know, the same thing with this, right? So this basically, like, if I deform it to make it work, then I did work on it by deforming it. And then when I did that, that was basically me moving it, mechanical energy, and I gave it potential. I gave it elastic potential though, okay? So just to kind of remind you how work is playing into this as well. Okay, so let's go back to the left now. Okay, so you're going to, where's my instructions? If you're using a ball, measure the height from which you drop the ball. Use the same height for every trial. So like I would do, just dropping it from a meter high, or whatever you measure out, that's what you decide. But make sure every single time you drop it from that same exact height. And then you're going to repeat that 5 times for each surface. So basically there's 3 different surfaces that you're going to use: a hard floor, a carpet, and then a cardboard. And so each one has 5 trials. So basically you're collecting 15 data, or 15 rebound heights, okay? Okay, so if you don't have a kind of bouncy ball, you can even take apart one of those pins that go like the clicker pins, and you can get that springed out like this kind. And you can use the spring at the top. I would use it as a last resort. Like I would try and find a ball, maybe even borrow one from a neighbor before I would use this, because I tried to do it and it was kind of hard with full. Maybe it was the spring that I had in my pen. Okay, so after that, you'll do the data analysis. And so it tells you, make sure you read through this on your Google Sheet. In the yellow bar at the top of each top of each column of data, include the units of measurement that you use. So that's just saying, like, make sure that you only put the units. Hate it when it does that. Right here. Don't put the units on every blue square. Only put them in the yellow square. And then you take an average. Do not use a calculator to average your data. The spreadsheet will do it for you. Part of the points on this is using the function. And so that's where you, and it gives you the instructions here. Highlight the data, click functions, and then select average, and your average will appear. Okay? All right. Would you like me to show you an example of collecting your data? Yes. Okay. Okay. All right. So you take the time to open up your assignment, or maybe go look for a ball. I'm going to go set up my hover cam so that I know that y'all can see me take some data real fast. Hopefully I don't spend more than 5 minutes. Right. I'm going to stop my video for just a moment. Anyone there? Okay. All right. All right, so you're gonna measure out a distance that you decide. So I'm just gonna, I'll use inches because I know y'all like inches. I never do that. That's like a first ever. But so you're measuring the height from, I'm measuring the rebound height from 3 different surfaces. And each time you do it, you want to drop it from the same height. So I'm going to drop it from this, which is at the top is 39 inches. And so when I drop it, I look to see which height it bounces back up from. And that's what I'm recording. That's my data. So if I drop it once, and so that rebound height went to 28 inches. And so it's a little bit of like an eyeball test. It's not, it's kind of hard to get an exact measurement with this. But then you would go to your where your data is, hard floor, 29 inches. Okay, but don't put the unit there, just the number, because you're going to type your units here. And then let me do it again. Now, once again, these are my numbers. These are just examples. These aren't yours. So don't record this data in yours. Do it again. That from 39 inches. Oh, that was like 29. So come over here. What did I say? 29. Okay. And then keep doing it. And then you're going to do it 3 more times. You have to have 5 trials, and then carpet. So for class, I have these little carpet squares, or they're like fuzzies. Oh, huh? My thing's in front of it. Okay. But at home, if you only have tile in your house, you can use a rug, or you can use a yoga mat, or whatever you have. I mean, if you you don't even have that, I mean, you could just use a sweater or like a shirt or something. And then, and so you're bouncing it on the fuzzy or the carpet. And so drop it from the same height and then record the rebound height. So that was like 21. It's okay if they're drastically different too, because honestly, it's a little bit of an eyeball test. You just kind of gotta guess. And then the last one is cardboard. Drop it from the same height. That was like 16. Okay, and then you just keep doing that. Okay, now, if you have a spring, or if you do have one of these popper toys, instead of dropping it and measuring the rebound height, what you do is you record the height at which it bounces up to on the different surfaces. So if I put it right here, and then any moment now. Okay. These red ones haven't been working very well. Any moment. Okay, that reached all the way to the top. So that's how you would do that one. You would see how far, and kind of if you use the spring and the pen, that's, you would do the same thing. You would just press it and see what it bounced up to on the different surfaces. Okay. So I think you can at least collect your data today. We have about 20 minutes left. It doesn't take long to get all the data, and at least get that done and collected today. Y'all have any questions? And feel free to, mine wasn't terribly precise, but that's why we're doing it 5 times. So that when we take that average, that it can be like as close to what it's supposed to be as possible. Okay. Okay. All right. So go ahead and start collecting your data and get started. Oh. Oh, when is this due? Tuesday. This is due Tuesday. Okay. Y'all are welcome to use and get your data now. I have the poppers. I have 3 bouncy balls, but I have these 2 that you can use. And then, how many? I had 5 of these, but and then these broken. So y'all can just come grab it what you need. And then also, if you use the poppers, I know they bounce kind of high, but right next to Christina to your left, I've measured out 2 meters on the wall. That is in meters though. And then if there's also another one over there at that, right next to that Be Your Own Kind of Beautiful. So if you want to use that instead of the meter stick, you are more than welcome to. All right, so y'all can get started. This is due Tuesday. Here it is. That's centimeters. Turn around. Turn it over. It's still it's centimeters both sides.
Can I see your screen again from earlier real quick?
Yeah, sure. Highlight I'll show you. So you're gonna have like numbers here. Is this what you wanted, Tiffany? And
Yes,
so
ma'am. Sorry, my mic was.
was that a yes?
Yes, ma'am.
So do you see how I highlighted it there? Okay. And then you go function, this one right here, this E. And then you click average.
Okay, thank you.
You're welcome. That's the end of first. We'll have maybe just a little bit more class time to finish on Monday, or I'll give you time, I'll do a short lesson and then allow you to spend some time working on it. Bye. Guys, that's the end of first. Y'all have a good rest of the day and a safe weekend.